Hey, welcome to Class 1 Precalculus review of Calculus BC. So for this course, you won't really need to know any calculus content. You don't really know BC. All you need to know is Precalc, and in this lesson, we're just going to review Precalc with a touch of calculus at the end. So first, let's go over right angle trig. So let's label the lengths A, B, and C. So we have sine theta. Let's call this theta. It's gonna be A over C. We have cosine theta, which is B over C. We have tangent theta, which is A over B. So these three are the main ones you need to know, and if you know these three, you know the other ones. So you have cosecant theta, which is 1 over sine theta. Then we have secant theta, and then we have cotangent theta. So it's C over A, this is C over B, this becomes B over A. You should know all these by heart. Don't bother memorizing it. We're going to go over an easier way of knowing it in a few slides. So now we're going to do degrees and radians. In calculus, we're going to deal with mostly radians. So if you're using a calculator, try to always use radians because that's what we use. It's just better. It just makes sense. So let's say angle A measures degrees, convert to radians. You should know how to do this already. So let's do degrees. So in 360 degrees, there are 2 pi radians. So that's how you convert. Or you can simplify and do pi over 180. And now you're into radians. And now we do the opposite, radians degrees. In 360 degrees, we have 2 pi radians, which is, you can just simplify r times 180 degrees over pi. And then you go to degrees. And make sure, if you're talking about degrees, always put the degree symbol. If you don't have the degree symbol, we always assume it's radians. Yes, now it's unit circle. This is the better way of doing trig. So it's the axes in the unit circle, all these lengths are 1. So in any point in the unit circle, we have an angle here. Then we draw lines here. The length here is cosine theta. The length here is sine theta, because this is 1. And if, as we discussed earlier, it makes sense. So the coordinate for this is cosine theta, sine theta. In fact, around the whole circle, all points are in the form cosine theta, sine theta. And by the way, you should know this too, so I don't really have to go that in depth into it. So let's just do one example. So this, let's pretend this is 45 degrees. But in actuality, you have to count this 182 because you use this as the reference point. So you go from here to here, it's 180 plus 45. So let's just find sine and cosine here. So this is 1. Sine of, let's just do 45 right now. Let's ignore the 180. So sine of 45 is 1 over root 2. 1 over root 2. Cosine is 1 over root 2 as well. And now, these are the 4 quadrants. This is negative, and this is also negative, since it's here. By the way, you should know this already, so yeah. And another thing, if you know sine theta and cosine theta, you already know tangent theta, because tangent theta is sine theta over cosine theta. And if you know sine theta, you know cosecant theta. You know cosine theta, you know secant theta. And if you know tan theta, you know cotangent theta. So by the unit circle, you can find every single trig function. You can evaluate it. Okay, next slide. Now we're evaluating expressions. It can be the sine, cosine, tangent, cosecant, secant, cotangent of pi fourths. So to solve these problems, draw a unit circle. Pi fourths is over here, and theta equals pi fourths. So let's find sine theta. Sine theta, we look at the height here, so it's 1 over root 2. For cosine theta, we look at the length here, it's also 1 over root 2. Then tangent theta is sine over cosine theta, which is root 2, so which is 1. And for cosecant theta, it's 1 over sine theta, so just root 2. Secant theta is 1 over cosine theta, it's also root 2. And cotangent theta, which is just the opposite of, it's 1 over tan theta, which is 1. So this was pretty simple. Next, we have domain and range. So domain of sine theta is all real numbers. Domain is what you can input into it. You can sine the angle of anything. It's periodic, so it's just going to keep going. So the domain is all real numbers, and the range for it, you can only get values of -1 to 1. No matter what you sine, it's always going to be in between -1 and 1. Same thing for cosine. You go from, the domain is all real numbers, and the range is from -1 to 1. Tangent theta is 1 over sine theta over cosine theta. The domain is, you can't take the tangent of every tangent anything because you have cosine theta, you can't divide by 0. So you do cosine theta equals 0. And these are the numbers you can't put into the domain. And the range is anything, it's all real numbers, it goes all the way up, all the way down. So it's a sine over cosine. If cosine can be infinitely small, close to 0, sine can be as high as 1. 1 divided by something that's close to 0 just shoots up. So that's why the range can be anything. And to show this, I'll actually go to the graph. This makes it a lot simpler. Sine here, you see it goes from -1 to 1. Same thing for cosine. Domain, all real numbers. In this case, tangent theta, as I said, when cosine theta equals 0, then there are asymptotes, which are at pi half, 3 pi half, as you can see here. Now for cosecant theta, it's 1 over sine theta, right? Then you set sine theta equal to 0, and that's where the asymptotes are. For secant theta, 1 over cosine theta, and you see that cosine theta equals 0, they're asymptotes. And you can see that these are exactly the same. The asymptotes are the same, not the graph. And for cotangent theta, you set it's the same as this one because you do cosine theta over sine theta. And you set sine theta equals 0 since you can't divide by 0, and the asymptotes occur when sine theta equals 0. So these have the same asymptotes. And for inverse trig, you just flip the domain in ranges for the regular ones. So basically, for regular trig, not inverse trig, you sine, cosine, you do a function on the angle, and then you get a number. And for the opposite, you inverse trig, a number, and then you get an angle. And here are the trig identities. We'll just go over all of them. Pythagorean identity, sine theta, cosine theta equals 1. It's basically the core of pre-calc. To get to the other ones, you divide by either sine squared theta or cosine squared theta, you get the other. Reciprocal identities, we talked about that, so we need to know this. Even odd identities, basically whether it's an even or odd function. This is basically, I'll just show you here. Sine theta for these two angles are the same because we look at the y coordinate, whereas let's do angle prime now, and whereas the cosine of these angles are the same, so that's why these are there. Prog to sum formulas, these you don't memorize. These are rarely used in calculus, at least, so you don't really have to know this. For sum to product, prog to sum, same thing. Double angle formula you should know because you can use this to simplify stuff. This is also the core of pre-calc, and you remember that For the double angle of cosine theta, there are multiple. And for tangent, it's the same. So these you should memorize. Cofunction identities, these are basically common sense. You can just use the unit circle. Oh, this is important. Basically, you can see in the graph, they're periodic. It's like sound, it's periodic. Okay. And now for sum and difference formulas, these are important. So if you don't know what these symbols are, if it's plus, minus, and minus, plus. So if it's x plus minus 1, and then x minus plus 1. Just basically what it is. Half angle formulas, you should know these too. Law of sines, I guess these are important, law of sines and cosines, but they're mostly for applications, and it's not really core in calc, even though we learned it in pre-calc. In area of a triangle, this is important, it's Heron's formula. So these identities, the main ones you have to know, most important is Pythagorean identities. If you take one thing away, it should be the Pythagorean identities. Secondary stuff you should know is double angle formulas, half angle formulas, and sum difference. And now, let's do a touch of calculus. So, difference quotient. In a few lessons, we're going to do the derivatives. And this is going to be the first way we evaluate a derivative. And if you remember from Algebra 1, Algebra 2, this looks extremely like slope, and it is slope. The derivative is the slope of a function at one point, the instantaneous rate of change. I don't know if you understand it now, but we're going to go more in depth into that in a few lessons. So that's going to be pretty fun. But first, we should know how to evaluate difference quotients. And also going a bit ahead of ourselves, if you take the limit as h approaches 0, you get the instantaneous rate of change. Because see, this is h, right? If h goes to 0, these 2 points will be closer and closer to each other. And if you take the limit, it's going to be pretty much exactly at that one point. And the difference quotient when h goes to 0, the limit as h approaches 0, is the slope of the tangent line. Right now it's secant line because it's not tangent yet. H isn't 0. So now, let's do an example. Difference quotient of x squared. So let's look at the formula again. So basically, when we evaluate derivatives, I'm going to warn you that we don't really use this. It's mostly for the beginning, it's more conceptual. So it's f of x plus h minus f of x over h. So f of x equals x squared. Let's find f of x plus h equals x plus h squared. Remember, it's not x squared plus h squared. It's not that. Don't do that. It's going to be x squared plus 2xh plus h squared. So let's do f of x plus h minus f of x. These cancel, so it's going to be 2xh plus h squared. But then you divide by h, which then you get 2x plus h. And that is our difference quotient. And let's relate that back to calculus. As I said, when h approaches 0, as limit as h approaches 0 of 2x plus h, that's how you find the derivative. Right now, I'm going to give you a glimpse into what we're going to do in the next class, which is limits. So as h approaches 0, the first way of evaluating limit is just plugging in. So if it plugs in, just direct substitution. It's the easiest way. It works. And that is 2x. You don't really need to know how to do this yet. You only need to know this for now. Once you know how to do these proficiently, it's going to be a lot easier to understand derivatives, limits, and etc. And this class is basically the basis of what we're going to learn in calc. We didn't really go heavy into calc today because without a strong foundation, you can't really learn much. So hopefully you understood a lot of it, and feel free to contact us if you have any questions. Thanks for listening.